Okay, so today the topic we are going to discuss is polymers, which are also known as macromolecules. All right. Okay, so let's first define what are polymers or what are macromolecules. So basically, a macromolecule or a polymer is a large molecule. It is a large molecule made by joining together many small molecules. All right, so this is the definition of polymers. A large molecule made up by joining together many small molecules. So basically, there are the term macromolecule. This term we have also used it in chemical bonding, right? So macromolecules, they're of two types. There are two types of macromolecules. If we talk about macromolecules, there are two different types of macromolecules. All right, so there are two different types of macromolecules. Right, so there are two different types of macromolecule. One is organic macromolecule, and the other one is inorganic macromolecules, right? So macromolecules, they are either organic or they are inorganic. The examples of inorganic macromolecules, you have learned them in chemical bonding. So basically, the examples of inorganic macromolecules are diamond, graphite, silicon dioxide. These are few examples you have learned in the inorganic section in chemical bonding, right? And how can we define inorganic macromolecules? Inorganic macromolecules, they are basically macromolecules which are made up of large number of these inorganic macromolecules. They are made up of large number of atoms. The macromolecule which is made up of large number of atoms connected to each other through covalent bonds, like diamond is made up of large number of carbon atoms, graphite is made up of large number of carbon atoms, silicon dioxide is made up of large number of silicon and oxygen atoms, right? So these are few examples of inorganic macromolecules. They are made up of large number of atoms. And when we define organic macromolecules, they are made up of the major difference between organic and inorganic macromolecules. Organic macromolecule, they are made up of large number of small molecules connected to each other through strong covalent bonds. Right, so organic macromolecules, they are made up of large number of small molecules. So the major difference is organic macromolecules are made up of large number of small molecules, and inorganic, they are made up of large number of atoms, right? They are made up of large number of atoms. So that's why organic macromolecules, they are also known as, for this reason, they are also known as polymers. We can also call them polymers, right? Inorganic macromolecules, they are not polymers, but organic macromolecules, they are also known as polymer. So this is the major difference, the basic difference between organic and inorganic macromolecules. All right, so this is what polymers are. So we've defined polymers that they are large molecules made up of or made by joining together small molecules. Now, when we talk about polymers, so the first thing you have to understand is that polymers are really big molecules. Right, they are really big molecules which are made up of thousands of small molecules, made up of thousands of small molecules. Right, so polymers, they are really big molecules which are made up of thousands of small molecules. These small molecules are also known as monomers. For small molecules, we use the term monomers. So they are made up of large number of monomers connected to each other through covalent bonds. For example, hemoglobin. Hemoglobin, it is found in our blood and it carries or it transfers oxygen in our body, right? And this hemoglobin, we are not talking about its function, that how it works, but the thing you have to remember is that it is made up of around 9,000 atoms and has a relative molecular mass of around 64,000. The monomers, which is it is made up of around 9,000 atoms and its molecular mass is around 64,000. So it is a really big molecule. So this type of molecules, they are known as polymers. These large molecules, they are known as polymers. Now, the thing which we have to discuss here is that how these polymers are formed. How these polymers are formed. So there are two different ways in which we can make polymers. One is known as addition polymerization and the other one is known as condensation polymerization. So there are two different ways in which we can make polymers. Right, there are two different ways in which we can make polymers. Number one is addition polymerization and number two is condensation polymerization. All right, so number one is addition polymerization and the other one is condensation polymerization. So first we would talk about addition polymerization and then we would discuss condensation polymerization. Another categorization which you have to understand is that polymers, this addition and condensation polymers, this is based on how they are made, right? And if we talk about their origin, so we can say that polymers can also be divided based on their origin as well, that there are two types of polymers, natural and synthetic, right? Natural polymers, for example, protein, carbohydrates, fats, they are natural polymers. And polythene, nylon, they are condensation polymers. So we would talk about them as well. But first, let's just talk about the addition polymers, that what are addition polymers, right? So addition polymers. Okay, so the first thing you have to understand about the addition polymers is that they are made by addition reactions. Addition polymers, they are made by addition reactions. Addition reactions, we have studied them in alkenes, in unsaturated hydrocarbons. So they are made by addition reactions. That means their monomers, the smaller units from which they are formed, so their monomers are unsaturated. All right, their monomers are unsaturated. And one more important thing is that no molecule or atoms, no molecules or atoms are lost during this process. All right, so they are made by addition reactions Addition polymers, they are made by addition reactions. Addition reactions in which the double bond of the unsaturated molecule is broken into and converts into single bond, and we add two groups on both the adjacent carbon atoms which have double bond. So that means the monomers must be unsaturated. And the other important thing is that no molecule or atoms are lost during this process, right? So these are addition polymers, and we get one large molecule as the only product. A large molecule would be the only product. All right, and the polymer which we get is known as addition polymer. So let's just take a simple example of addition polymers. Let's suppose if the monomer is ethene. Now ethene is an alkene with two carbon atoms. So it has two hydrogens with this carbon atom, and this is our monomer, right? Monomer is ethene. And we are saying that when large number of ethene molecules, like 10,000 or 20,000 or 50,000, so I just simply say that we have n number of molecules, and n represents a large number, right? N represent a large number. It could be 10,000 or 20,000 or 50,000. So when large number of ethene molecules combine, so let's just do a few examples, ethene molecules. Let's say this is one ethene molecule. Okay, so let's just say this is another ethene molecule and another ethene molecule. So I will draw three ethene molecules, and you just have to assume that we have large number of ethene molecules which we are representing with n. Right, so when these ethene molecules, addition reactions occur at high temperature and pressure in the presence of a suitable catalyst. So the conditions would be high temperature and pressure in the presence of a suitable catalyst at high temperature and pressure, and in the presence of a suitable catalyst. In the presence of suitable catalyst, the double bonds will break. The double bonds will break partially. So a single bond will remain between both the carbon atoms, right? And molecules will connect with each other. Molecules will connect with each other. So how would this happen? Let's just think that we have this carbon atom and this carbon atom, they have a double bond. So when high temperature and pressure is applied, this double bond in a single bond, let's just say if I talk about a single bond, you all know this thing, that when two atoms form a bond between each other, let's say if two carbon atoms are forming a bond between each other, that means one of the electron is from one carbon atom and the other electron is from the other carbon atom. So when the bond breaks, this carbon atom take back its electron and this carbon atom take back its electron. So this is what happens here, that we break this double bond, this bond. It breaks due to high temperature and pressure, and this carbon atom gains its electron and this carbon atom gains its electron. Right, and the same thing happens here. This carbon atom take back its electron, this carbon atom take back its electron. The same thing happens here. So that means now each carbon atom, what happened here is that the double bonds would break, and let's say that this double bond is broken, this bond is broken, and this bond is broken. And once these double bonds breaks down, what happens here is that each carbon atom now regain its electron, because when double bond breaks, both the carbon atoms will take back their electron. So now they have this free electron available, right? And once they got this free electron, what happens is that these two molecules, let's say this is molecule 1 and this is molecule 2. So these two molecules, they will make the carbon atom of molecule 1 and the carbon atom of molecule 2 will make a single bond with each other, right? So it will share this electron, this will also share his electron, and another bond, a single bond, will be formed between these two carbon atoms. This is how chain length increases. So now we have four carbon atoms. Now we have four carbon atoms in the molecule. The same thing happens between molecule number 2 and molecule number 3. Both the carbon atoms will share their electron. So now we have 6 carbon atoms in the molecule. And this thing goes on and on because we have large number of molecules, right? So this thing would be continued on the right hand side, and this thing would be continued on the left hand side. So the type of structure which we get here is, let me just draw the example, the structure which we get. Let's say this was the first ethene, double bond breaks. Now we have only a single bond between both carbon atoms. It makes a single bond with another ethene molecule. This is the another ethene molecule. Then we have another ethene molecule. So this is how chain length increases. Large number of small molecules connected to each other through covalent bonds, right? So this is the bond formed between both the molecules. This is the bond form, and this is another bond form. So how many monomers I have drawn in this structure? Let's just draw another monomer, right? So this thing goes forever, like I don't know how many molecules we have, but it would be a very large structure, right? So continues on the right hand side and continues. A bond which we draw on the left and right side, this bond, it shows the continuity of the structure, that the structure is continued on both left and right hand side, right? So how many molecules we have drawn here? How many small molecules we have drawn here? This is molecule 1, this is molecule 2, this is molecule 3, this is molecule 4, this is molecule 5, right? So what have we discussed here is that the addition polymers, they are formed from monomers, alkenes. The double bond breaks when they are subjected to high temperature and pressure, and these small molecules make a single covalent bond between each other, due to which the chain length increases, right? And as we have discussed that no molecules or atoms are lost during this process. So you can see that all that we have done here is we just have make a bond between the molecules. So no molecule or atom is lost in this structure, and now we have got a bigger structure, right? So this is addition polymerization. So I hope everyone understands this now. And a few more important things about this structure is the name of this structure would be. Now, if I want to write this in a chemical equation form, addition polymerization. So how can we write it in the chemical equation form? So let's say we can say that we have an ethene molecule, a large number of ethene molecule, right? So large number we can represent it by N. So we have large number of ethene molecules which are subjected to high temperature and pressure. At this level, no one will ask you about the temperature and pressure, exact temperature and pressure, and catalyst. You can just simply say that a suitable catalyst will be used, right? And what happens here is that the double bond breaks. It converts into single bond, and this carbon atom makes a single bond with its neighboring carbon atom, and this will make a single bond with its neighboring carbon atom, and this thing would be continued on both sides. And we just draw a bracket here and write N. So the monomer that we had was ethene, and the name of the polymer would be based on the name of monomer. We just simply add a prefix poly. So this would be polyethene. So this is addition polymerization.